Okay, so in this video, we're going to look at task 8. It is on page 24. We're starting where it says number 4, can the lengths of 2, 3, and 6 be the lengths of a triangle? And it talks about the triangle inequality, and then we're going to just do the rest of the problems on that page. So on the PowerPoint for it, I have access to kind of 3 different applets. This first one is an exploration. So if you wanted to go into Desmo's classroom and kind of explore the triangle inequality and figure it out for yourself, you could walk through this applet. It's pretty cool. It would be something, if you were like teaching this, that I would definitely recommend using with students to help them discover it. And then the other 2 are both ones to just kind of show you. So there's 2 different ones on GeoGebra. This one is nice that you can like move them to actually see, like, does it make a triangle? But sometimes it's really hard to get them to attach. Like, I know when it's a triangle or not, and sometimes I had a really hard time creating a triangle. So in that case, this other one is better because it just does it for you. But this one, the other one kind of conceptually shows you like why it works and why it doesn't, more than this applet. But they're both there that you could play around with. So what we're going to do is we're going to see if the lengths 2, 3, and 6 can be the lengths of the sides of a triangle. So you could, again, pause and go to those applets and try it and see if you can get it to be a triangle or not, and then mess around and change the measurements to see when it is a triangle and when it's not. So what it was 2, 3, and 6. So I'm going to do 2, 3, and change this to 6. Okay, and see, did it make a triangle? And on this one, well, again, it's obvious to tell it did not make a triangle. If I go to the other one, like, it's easy to see, like, okay, there's no way I could get this to be a triangle because this side 6 is way too long to get that to be a triangle. So let me adjust the smallest side a little bit. So if I make it 3, I still can't get it to be a triangle. This side is too short, or this one is too long to get them to be. But let's say if I change this one to 4, and again, you're gonna have to mess with it a little bit to get it to work. Okay, so it took me a little bit of time, but as you can see, I can get those 3 to be a triangle. Like I said, this one's a little bit trickier to get them to match up. But if you do the other one and you do 4, 6, and 3, and 6, you can see it does make a triangle. Like, this one's easier to do. But when I had it at 3, you can see, okay, it doesn't make a triangle. But as soon as I went to 3.1, it did. And so there's this relationship called the triangle inequality theorem that helps us determine that if we have 3 sides, whether it would make a triangle or not. And the key thing is that when you add the 2 smaller sides, they have to be larger than the third. So like when I make this 3, when it's equal, it made this straight line. And so there would be no way to get them to be a triangle and have 3 angles that add up to 180. If I do it 2, the same thing, and it's more obvious, like on that other applet, I could never get them to connect. The long side is too long. But as soon as I get to 3.1, I can make a triangle. And that's because 3.1 plus 3 is bigger than 6. And I could like keep going until eventually, okay, 3 plus 6 now is 9. And now this side is too big once I change to A. So this is called the triangle inequality theorem. And what the triangle inequality theorem says is that the sum of any two sides need to be greater than the measure of the third side. And that's what we saw. If I add two sides, it has to be greater than the third to be a triangle. And if we come back to this question, just to answer it, can the lengths of 2, 3, and 6 be the length of sides of a triangle? And the answer is no, because 2 plus 3 equals 5, which is less than 6. And so the sum of two sides is not greater than the third. And therefore it won't make a triangle. But for the triangle inequality theorem, as long as the sum of any two sides are greater than the third, then it is. Now, we only need to check that the small plus the medium is greater than the large. And if you think about it, the reason is that, okay, if I am checking the medium plus the large, that has to be greater than the small because we know both of them are greater than the small. And if I do like small plus large, well, that has to be greater than the medium because the large is already greater than the medium by definition. And so the only one we have to check is that the small plus the medium side is greater than the large, because that's the only one that could possibly fail. And that's called the triangle inequality theorem. So for these, if we want to check, can these be the length of the side of a triangle? I find the small and the medium, and just make sure they're not always in order. So just pay attention, and I add them. So 3 plus 4 is 7, and that is greater than 5. So the small plus the medium is greater than the large. And this is a triangle. So we do the same thing for B. This is my small, this is my medium, this is my large. 8 plus 8 equals 16. And 16 is equal to 16. So this is not a triangle. And again, if you had to explain why, it's because the small plus the medium is not greater than the large. And then the last one, this is my small, this is my medium, this is my large. 7 plus 10 is 17. That's greater than 14. So yes, a triangle. Okay, and again, the reason is the small plus the medium is greater than the large. Okay, so that's the triangle inequality theorem. And once I know it's a triangle, we can determine what type of triangle it is, whether it's a obtuse, or right based on the side. So we don't even have to know the angle measure. We know we can just check it, but you have to know it's a triangle. So never check it until after you check the triangle inequality theorem and make sure it's a triangle. But how you determine if it's right, it's a very famous theorem. It's that Pythagorean theorem. So the Pythagorean theorem says that, sorry, my pen is going crazy.